Hello guys. Here's the second video on solving systems of equations using the elimination method. So these examples are slightly different because if you notice, we don't have opposite terms here, right? So for example, we have a 1y in the first equation and a 1y in the second equation, but they're not opposites because they're both positive, right? And we know that when we want to use elimination to solve, we need two terms that have the same variable, same coefficient, and also um, are opposites, right? Meaning that one is positive and one is negative, so that we can cancel them out when we add. So in an example where we don't have opposites, we need to perform an operation to make them opposites before we can add and solve. If something is positive, right? If a term or a value or a variable is positive and we're trying to make it negative, all we have to do is multiply that by -1, right? So just for example, if I had the number 2 and I was trying to make this 2 negative, all I would have to do is multiply this 2 by -1. 2 times -1 is just -2, right? Similarly, if I had the variable 2x and I wanted to make the 2x negative, all I would need to do is multiply this 2x by -1. -1 times 2x is -2x. So similarly, if we want to have opposites in our equation so that we can use elimination to solve, we would need to multiply one of the equations by -1 first before we add them together. So if we do that, right, say I take the first equation, the second equation, and I multiply that by -1, right? I'm going to now distribute this -1 to every term in the parentheses, right? So -1 times -3x is positive 3x. -1 times positive y is -y. And -1 times -5 is positive 5. So I've multiplied the second equation by -1. I distributed the -1 to every term in the parentheses, and now I have this new equation. I'm just going to add my new equation back to the first equation that I had. So I'm going to take my first equation and just rewrite it on top of the equation that I just got. So 8x plus y is equal to -16. Now, if you notice, right, I have 1y, and now they're opposites of each other, right? One is positive, the other is negative. So I can easily use the elimination method to solve this. Since they're opposites, we just add the two equations together. 8x plus 3x is 11x. -y plus y, or y minus y, is just going to cancel out. So 11x is equal to -16 plus 5, which is just -11. Last step to solve for x is to divide both sides by 11. The 11s will cancel out, and we'll have x is equal to -1. Now that I know that x is equal to -1, I can just substitute that -1 back into the first equation for x and then solve for y. So if we use the first equation, 8x plus y is equal to -16. I know that x is -1, so I'm going to plug in -1 for x, plus y is equal to -16. 8 times -1 is -8, plus y equals -16. I need to get that y by itself, so I'm going to use inverse operations to move the 8 over. So we'll add 8 to both sides. That cancels out, and y is equal to -8. And that's it. The solution to this system is -1, -8. Okay, let's look at another example. 7x plus 2y equals 24. 8x plus 2y equals 30. So in both equations, we have this 2y, right? Same term, same coefficient, same variable, but they're not opposites of each other because they're both positive, right? And to use elimination to solve a system, we would like to have one positive and one negative. So in order to make one of these equations negative, I would need to multiply one of them by -1. So if I multiply the second equation by -1, I'm going to distribute that -1 to every term inside of the parentheses. -1 times 8x is -8x. -1 times 2y is -2y. And -1 times 30 is -30. Then I'm just going to rewrite my first equation on top of the equation that I just found. 7x plus 2y is equal to 24. Now that I have opposites in my equations, I can just use elimination and solve, right? So we can just add the two equations together and simplify. So if we're adding these together, 7x minus 8x, or 7x plus -8x is just going to be -x. 2y minus 2y is going to cancel. That's what we want. And 24 minus 30 is just -6. Last step to solve for x here is to divide both sides by -1. And we're left with x is equal to +6. Now that I know that x is equal to -6, I can just substitute that -6 back for x in one of the equations and solve for y. So using the first equation, 7x plus 2y equals 24. I know that x is 6, so I'm going to plug in 6 for x. 7 times 6 is just 42, plus 2y is equal to 24. I need to move the 42 over to the right side, so I'm going to subtract 42 from both sides. That will cancel, and we're left with 2y is equal to 24 minus 42 is just -18. And then our last step here to solve for y is to divide both sides by 2. This will cancel, and y is equal to -9. So our solution here is 6, -9. All right, let's look at another example. So we've got -2x minus 9y equals -25, -4x minus 9y equals -23. So we have the same variable and coefficient, right? 9y in the first equation, 9y in the second equation, but they're not opposites of each other because they're both negatives, right? And to use elimination, we need one to be negative and we need the other to be positive. So same step, right? It doesn't matter that both of these are negative. We will still need to multiply one of them by a -1. So to do that, we just multiply the second equation by -1, and then we distribute. -1 times -4x is +4x. -1 times -9y is +9y. And -1 times -23 is +23. Next, I'm just going to rewrite my first equation on top of this. So -2x minus 9y is equal to -25. I just rewrote this first equation on top of the equation that I just solved. Great. Now that we have opposites, right, -9y and +9y, we can add the two equations together and use elimination to solve. So if we add these two together, I'm going to add the second equation to the first one. -2 plus 4, -2x plus 4x is just 2x. -9y plus 9y will cancel. And -25 plus 23 is just -2. Last step here to solve for x is to divide both sides by 2. This will cancel, and x is equal to -1. Now that I know that x is equal to -1, I can take that -1 and plug it back into one of the equations and solve for y. So if we use the first equation, we have -2x minus 9y is equal to -25. I know that x is -1, so I'm going to plug in -1 for x. So -2 times -1 minus 9y is equal to -25. -2 times -1 is +2, minus 9y is equal to -25. I need to get this -9y by itself, so I'm going to move the 2 over. We do the opposite, so I'm going to subtract 2 from both sides. This will cancel, and we're left with -9y equals -25 minus 2 is -27. Last step to solve for y is to divide both sides by the number in front of y, so we're dividing both sides by -9. -9 and -9 will cancel, and y is equal to +3. So our solution here is -1, 3. All right, I think we have one more example. Okay, so -6x plus 6y is equal to 6, and -6x plus 3y is equal to -12. So here, this one's a little bit different, right? Because now the y's are actually not the same, right? We have a 6y in the first equation and a 3y in the second equation. However, the x's actually are the same, right? So we have a 6x up here and the 6x down here. Those are both the same variables and the same coefficients, right? But they're not both opposites, right? Because both of them are actually negative, and to use elimination, we need one negative and one positive. So the step is still the same, right? We have two terms that have the same coefficient and variable, but they're not opposites. So to get them to be opposites, we're still going to multiply one of those equations by -1. And then let's distribute. -1 times -6x is +6x. -1 times 3y is -3y. And -1 times -12 is +12. Next, I'm just going to rewrite that first equation back on top of what I just found. So -6x plus 6y equals 6. Now I see that I have opposites of each other, right? I have a -6x and a +6x. So now I can use elimination to solve, right? We're still going to add the equations to each other. -6x plus 6x is going to cancel out. And that's okay that it's an x value that's being canceled out. It doesn't matter which of the variables are being canceled out, as long as one is being canceled or eliminated so that we can solve for the other. So -6 plus 6x is going to cancel. 6y minus 3y is just 3y. And 6 plus 12 is just going to be 18. Last step to solve for y here is to divide both sides by 3. And we'll see that y is equal to 6. All right, now that I know that y is equal to 6, I can go back and plug in this y value into the first equation or the second equation, doesn't matter, and solve for x. So using the first equation, -6x plus 6y is equal to 6. Wow, that's all sixes. Okay, I know that y is equal to 6, so I'm going to plug in 6 for y. It's crazy. -6x. 6 times 6 is 36, equals 6. I need to get the 6x by itself, so I'm going to move the 36 over. I'll do the opposite, so I'll subtract 36 from both sides. This will cancel, and we'll have -6x is equal to 6 minus 36 is just -30. Last step to solve for x is to divide both sides by -6. And we'll see that x is equal to +5. So our solution here is 6, 5. No, our solution is not 6, 5, sorry. It's 5, 6, right? X value first. All right, so this one was just different because it wasn't the y's that were opposite, it's where it was the x that was opposite, but it's still the same step. We still needed to multiply by -1 to make them opposites. Then we added the two equations together, solved for y, and then used their y value to solve for x. So same steps, we just found the y value first. Okay, that's all for that type, solving when we don't have opposites. I'm not sure if I over-explained, but I hope it was helpful.